Hey everybody, this is Larry. This is day 21 of Advent of Code. I need a haircut, but that's not really what we're doing today. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's challenge. Doing this live, there's about 55 seconds to start. Yeah, the explanation will be toward the end because, well, I don't know, I'm doing this live, so I'm trying to get on the leaderboard a little bit. Yeah. What do y'all think about this world map or whatever it's called? There's like a little monkey thing on. Oh, is that a monkey or a house or I don't know what it is or hut. I have not read the story at all this year, so I don't know what the story is about. But it looks like we're in like some faraway land. It looks fun. I don't know. I just came back from faraway lands myself, so yeah. I am so jet lagged. I've been sleeping in and out all day, so we'll see how this goes. I am like my head is not in the game, but there's only 10 seconds to go, so whether it is in the game or not, it doesn't matter. I just have to do it. All right, 5, 4, 3, 2, 1, go go go. Okay. This is straightforward. This is gonna be a typing contest for a lot of people, I think. Okay. Too lazy to do it the proper way. So maybe I'll come to regret it. We'll see. Okay. Man, I don't even know how to write this anymore. What are you doing? It's an awkward way of writing it. Okay. Let's try 16. Oh no, 6, right? That's not good. Oh, what the? Why would I write it that way? Okay, 12 is not good. Oh well. End of leaderboard. Why is this wrong? Exactly 6. What? Why am I wrong? Tell me why. See what the? Did I messed up? Why, Larry? You wrote this way. Okay, 16. And I have to change this to 64. Okay. 3598. 154. I was too slow. I mean, I knew that. The debugging killed me. Minor typo or not. I don't know what I call it, typo, but okay. Exactly how many steps? Okay, and then this is just that's not great. 2 more steps. No, that's not going to cut it. How do I do? I was hoping this would work, but this was an easy modification. Wasn't sure though. need to do it faster, or do I need to do? I mean, okay. This is I mean 26 million, not 2 million. That's a lot. And we're still at 1,000, parsing a lot of steps. And there's already 4 million things into the thing. I mean, we won't even fit it in memory, because this is, even if we just naively times it by 1,000. I had my chance of leaderboard out. If I could do it start too. I can't believe I started 0, that was the typo. Waiting for it. Alright, this is never gonna finish, but I'm still thinking though, I'm not just like waiting for it to be done. Okay, so the borders, can I do some even speed up? Yeah, I guess this is where we're starting to run out of memory, maybe. Yeah, there's no way we can do it this way. Can we do a binary search? Is there a binary search? You can't do it per cell because it already has, like, I think half of these cells are the answers, right? So that means that okay, so we draw the border and then we keep on drawing the borders. What is the distance on the border? Alright, maybe we can play around that way. Let's say we have 3. Alright, so 30 we have, this is going to be, oh, not exactly this, half of this. Actually, that's a little surprising maybe, but maybe not, it doesn't. Okay, what I actually don't want, oh, I don't need this. Let's take the test input for a second. And now these are the farthest. The farthest don't have to be in the border, but the border one is what connects everything. How many people have gotten it yet? Am I doing this? Oh, no one got the second one yet, huh? So it's not just me not knowing. Okay. Okay, let's say we have some borders and then now kind of and then the shortest distance for the borders are just going to be and then you fill it in, and you could fill it in one at a time if you really want to, but this point is going to be just the closest point to here. Default. That's not even necessarily true yet, is it? And also you could have two different things. No, if you switch out. No, but then you have like these shortest path combined, so I don't know that I can do that easily. This is not going to be a short one. I don't expect there to be a pattern, but I was thinking about like disconnecting the borders to kind of speed it up, so that now you're searching by cells or whatever. But I don't even know if that's quite easy to do. So then basically you're doing a breadth of search on all these things. You still have to go for all of those, so like, I don't know, each of them are at most 14 away, so that means that we do a breadth of search on each of these things. It's going to take a million depth away, so it's 14, right? And even more. You're 14 away. In the farthest point, and that it should be less even. But you just keep on going to the right here. As every drop down that way. for testing. I guess I should double check that this works. Oops. That's not quite right. Oh no, it is. I print too many things. Still print too many things. This may be a go sleep early and maybe figure it out tomorrow kind of thing, but okay. So I mean, code is right, just doesn't scale. Even 500 is taking a while. On the test, even. You know, 1,000 is taking 2 seconds. Let alone that many. I mean, I think the idea will probably stem from combining the same maps and then repeating them. But I still don't know how to do it. I mean, okay, let's say we can combine 2 maps, which is duplicates of itself. What does that mean? You still have to do like a breadth first search of like 1,000,000, so it only speeds up like 10 times. But if it takes like, it still takes a while. And it's not even clear that it is that faster, because you have to combine it from different sides. I don't think there's any pattern, right? Like with this pattern, then that would be nuts. Nuts. Six to 8 is 10. 9, 16, 30. I don't think that's everything, but. Is there anything specific about this map? Oh, that's cheating. Do you see this? Is this the case here? No, that's not the case here. The cheating thing is, well, I don't know if this is true for vertically, but it has a straight point up and down. That is shenanigans. Okay. That means that now the problem is a little different, right? That means now from one cell to the middle of the other cell, it's going to be from that. So that means that the closest point is going to be the middle of these things. That is okay. Now we have at least a point of attack. I don't know if this is going to be right, but you know, let's pick this. Was it 16? Okay. I could. It went from unsolvable to I hate this, but still solvable maybe. So okay. So let's see. Just copying it over. But I'm just gonna return so that I don't accidentally want it, even though I have a thingy for it. But okay, so then now how do I want to write it? Right. Oh. So that means that the shortest point is just going to be, so there's going to be only 8 possible maps of the shortest points. So then now you could connect them very quickly. This is annoying to write though, but I think I could do it. Okay. Is that true? What's the quickest point? Because there's no diagonal. The quickest point is always going to be just straight right, straight left. And then, okay, because there's no like weird, yeah, okay. Okay, how do I want to write this? Okay, how do I'm trying to figure out how I want to figure it out. Uh, 131 by 131, so that means I think it just means like it's 65 or whatever it is, 67, yeah. So that means that whatever, this is just a big random number. I don't even know what that is. Yeah, 0, 65, SX, or SY, I guess they're the same, it doesn't matter. Oh, that's unfortunate. I forgot to do the okay, so it's 65 distance away. Just want to verify that I didn't lie. And then no, what am I doing? Okay, so they're all 65 distances away. That means now $65. We still have to be careful though. I mean, it's 2 million, so that means that there's only 1 million different cells. So you do 1 million across or something like this, right? Yeah, this is still annoying as hay to get right, but because you can't just do like a loop of 1 million over times 1 million. So, but that means you only have to do the fringes, which I guess there's 1 million of them, because if you think about the shape as a diamond, of but there's 1 million of them, and then on the border there's only 4 million cells, so, or something like this, right? Or 500,000, I guess, if you want to be more precise. Okay, so then now mx is equal to this number. I'm taking my time. I don't think I'm gonna get leaderboard, but that's fine. So let's see. Okay, 407,000. So then now you start, and every cell after inside the other thing should be good, right? I don't need this. Okay, so you have this distance thing. This isn't right anymore, but then now so there are really only 4 different shapes, not 8 for actually, but okay. Well, actually, I guess there's still 8 actually. Wait, 1, 2, 3, 4, yeah, 8. Okay, fine. But still only some people got it. But that's such a annoying thing to catch, though. I don't know that it is even possible, but okay. So then now what do I want to do? So I go up 400 million steps or whatever. That's the thing, is that you can't test this because this or my code is not true for this particular case. So it's kind of a YOLO if whether this is right or not. But okay, fine. So then now it's gonna be. Oh no, it's not over 65. It's over 165 is only from the first thing. So okay. So top maybe. All right, we need to calculate. This part we already wrote, I guess. This is just gonna be in the middle, so fine. Maybe we don't even need this. Okay. And then now we just return. Okay. I mean, I know how to do this. It may take forever, but I know how to do this. I'm okay. Actually, do I want to do it this way? No, let's make it dumber. But no. The way that we do it, all these are the same. We don't need heap by definition, because if it's not, no, they should be all the same. Okay, because it should be Manhattan Destiny. Okay, fine. I messed up here. Maybe still do it this way, but they all should be the same. I have no expectation of finishing in the leaderboard this time, that's why I don't care that much. But okay. And now actually I guess that's fine. I just write the same thing I did before. Okay, and then now we go top. So the first one should be 1 and then 3. How do I write a diamond for loop? I don't even remember anymore. Something like dx is equal to 0. It's 131 actually, right? But that means that I kind of did it the other way, but whatever, same difference. And then okay, so there's 202,000 things away. 202,000 things away. So then now, okay, let's calculate the 4 first. 4 is, it's just a parity map, right? So it doesn't even matter. Do I change parity? After 65, I think 66. That means that the S's are okay, 131 steps away. Right. I'm just trying to do a small example. Let me draw it out actually. Let's say about 3. And now 1, 2, 3. That means now there are 2 full ones. There's odd one and an even one. This is very annoying to get right. I don't think this is hard anymore, but it is definitely not easy. Oh, did I get rid of the SY stuff? I don't know why I did that. Luckily, I have the other thing, so I guess that's fine. So even is when the starting point is 0, right? This is going to be so annoying actually. That means that there's more different shapes. But that part is not that bad. We that part's not that bad, maybe. I don't know. Because for each of these things we're calculating anyway. Is 131 times 131, 17,000 times 200,000 is still going to be, is that 3 billion? 3 billion? I mean, 01, maybe. Anyway, okay, fine. I guess it is just one minus the other actually. I didn't even need to do that. But where am I getting now? That's why I won these, just so that I can. Oh, whoops. Okay. And then now for each row. Oh, what did I do? Okay, tell me that. So now the checker flags, checker thingies. Okay, now I'm trying to figure out how to write a diamond. I mean, that part is not that hard, but I am lazy. So the invariant is that x plus y is equal to this number, right? Maybe I'm off by 1, but so then now the top one is going to be the bottom. The bottom is r minus 1. SY. Yeah. And the distance is going to be 65 to get to the border, plus 1, 3. So 65 plus away times 131 plus 1 or something, maybe. I mean, there's no way for me to. This is going to be a nightmare to debug as well, even when I. This is going to be a nightmare to debug even when I do get it right. I mean, when I get most of the code right, but I'm like off by one or messing with some ideas or something. Why is this not right? Oh, of course my Amex is right. Did I return something? Why do I not print? No. Did I not save? I don't know. Okay. But it still returns 0. What the should roll? I mean, it could be just this off by 1, but still. I mean, okay, but already I'm not very confident, right? No. Like, this is just ridiculous. I don't know that I can is it closer or is it always this number? I guess it's always this number for the numbers that we care about. Maybe. So then that means we don't need to do 200,000. We only need to do 8, but it's still not so good. Can I just add cash? Does that work? I think I have to change into a frozen list or something. Well, that's no good. Ready? W attribute. Where do I put it? Oh. Did I just pip it? Oh no, I did not pip here. That's why the pip was being a little weird. Oh, did I just call the wrong one? Unhashable type list. Isn't that what I'm here for? I have to do freeze. Oh, I'm just being dumb. Because then now I don't know that these are. It's just like I'm confident I'll get it, but eventually. But it's just a nightmare to debug without, like, I don't know. Yeah, so this doesn't actually matter. So then going from the top, and then also from the left, which is going to be SX C-1, and that's assuming a lot of things are right? And now going to the right. It's an answer. Is it the answer? Okay, actually what I should do is now take back the part 1, so then I can kind of look at, I don't think I did it too badly, but let's just say, so 131, so let's just say 2000 steps away. And then now we can maybe cheat on this one, for maybe 2001, just to get an odd number. So then now we have, okay, I don't know, I didn't think about that, but now we have a verification, which is good. I don't know why this takes so long. Is that part 1 or part 2? Why is part 1 take so long? No, for MX is equal to 20. Oh no, 2001. Was 2001 so long? Okay, maybe like 501 then. Just maybe 701. Really? Oh. Okay, so now we have a basis to compare with. Oh no, not test. Oh. Don't want it for test. Okay, so now we have an answer that I think we know are right. Right. Actually, let's do 1000, because then I can run it on the test and not feel that bad about it. Because the test, okay, so 1000 is still right, so the code is still right. That's what I wanted to know. And then now part 1 is going to be right. It takes a while, but right. This is so fast, but also wrong. Okay, and then now I have to do the in between, which is not the easy part. All right. So for the first row, the second row is going to be 1, and then 3, and so forth. So how do you know if it's odd or even? So if it's 1 away, it's odd. If it's 2 away, and then now this cell is going to be away, -1. So it's away -1, mod 2. So that is the cell properly. And this is away -x -1. So that's the one that's directly on top or in the middle. And that's the only one that sticks out, because all the other is that true? No, I don't think so. Because if you have 3, then now the opposite color is the one that you want one more of. Okay, so let's say x, right, is x is 1 or x is 0. Maybe that's too much anyway. I'm doing this very slowly because I'm just trying to, well, I don't know, just trying to get it. So okay, so x is equal to 1, there's 1, x is equal to 2, there's 3, so there's going to be x times, well, it's x times 2 minus 1 minus 2. Minus 2 because of these 2. And then now, so that's the number of things. If that's one thing, it is an array of there's so many like off by 1 chances. That's the part that I'm just like so not happy about. Okay, so if there's one cell, if this is one cell, right, that's the number of things, right? But one of them is more. So then this is this, even plus odd times this. And over 2. And then now if array minus x mod 2 is equal to 0. I don't know if this is right. I think it may be a trial and error situation just because I don't have the brain cells for this. I mean, it runs pretty fast, so that's good. I wonder if I run the first part in a... Like, I want to be able to verify this without writing the rest of the code, because that is just... I mean, it's going to look more the same, so it's not that bad, but... Can I write code to verify this easily in part 1? It's just basically and then all right, let's just do it. I don't know, let's just keep going. And now bottom is mostly the same, so actually I think you have to do it differently, because now this is 0 for the bottom, and yeah, and that changes things a little bit, but still okay. That seems like we're off by a lot, to be honest, because this should be like very close. We're only missing one line, so it's going to be SX. Did I do this right? So if we're going to the left, then it's going to be SX and then R minus 1. Okay. Oh, C minus 1. I guess it's the same, but I mean, I think I'm functionally done. I'm not actually done though, because of, I don't know, it's a mess. So then now it is going to be array minus 2 divided by 2, right? And then I guess the middle one is always even. Oh, but then the extra one is not always even, so. And this is not right, but it is approximately right, but it is not actually right. I mean, we're off by 1 anyway. I don't know why there's this thing. But I don't know. This is so weird. I feel like I'm... Like if this is too far, I should return 0 or close to it. Oh, maybe not. Why? How? That doesn't make sense. This should not get bigger with this. Am I doing this right? Economics. But that shouldn't change anything, but why would that be the case? Oh, because this has more for loop. Okay, that's fine, I think. Maybe. I mean, we're off by one, we're off by one. Wait. I'm off by a lot. Okay, well. Okay, so that's good. Yeah, that okay, so that is actually what we want. This. Okay. Because then now the border distance is yeah, okay. We're missing by a bunch. Am I doing this wrong? I mean, yes, we are clearly doing this wrong, but how? Dun, dun, dun. I thought it'll be like more like off by a little bit, but this is off by half, which is a lot. We can maybe do MX for a little bit smaller to verify. Let's say 500. Okay, so this is still right for part one. So that means this is still right for part one, and we're really undercounting. And I think the formula should be the same anyway. So this is faster for testing. Roughly. Okay. Yeah, I mean, okay, so the border distance is away. Is away right? No, it should be right. But all these other junk. I guess we're off by a little bit or a lot. This is fine, this is fine. Is this fine? Am I divided by 2 by accident? Does that make sense though? No, I don't think that makes sense. That I don't divide by 2. And even then I'm off by a lot though. So that is just really awkward because I thought it would be closer and that we just only fidget with off by ones. This is much closer, so maybe I was just off by 1 on that, but still not close enough, to be honest. Where's my print statements? That's what I'm looking for actually. There's this one. I guess I already removed the other one. Oh yeah, I did. Oh, I did. Okay. The other one's just the size of the grid. Okay. I think I just need to draw it out. I think I'm trying to do too much in my head. Okay, so let's say, let's print a wave right now. So it's 3 steps away for 500. Okay, so that is that true? No, 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 I'm gonna draw it out. So this is 65, 66, and then like plus 131, so 197, 131, 328. Man, I'm just gonna use a calculator. My brain is not. Oh no, I got it right. Good job, Larry. 459. All right. Okay. Is my border distance 459? Okay, good. Am I right? I mean, that one, if I'm off by 1, it shouldn't be off by 40,000. So, okay, so I think it's probably something with the for loop formulas. Okay, so then now, let's say this is whatever, and we have all the diagonal. So then now, if x is 1, which we don't really use anyway, if x is 1, we have 1 cell, okay? If x is 1, we have 1 cell. This is what this part is doing. I think I messed that up. Maybe I don't need a -2. Oh, I think the -2 is from when x starts at 0. I think I did that wrong. Okay, now we're doing too much, which is maybe good. I don't know. Do I need array +1? I don't know if this is good. But then now array in this case is 3, and we have 3. So actually that is what I expect. And now let's say this is even, then this is odd, even, odd. So then we might as well debug that. X is 1. It should be odd. So let's make sure that this is the case. Why are you being silly? Oh, there's a y there I didn't even see. Tell me why. Okay, so 1 is even, so that's off. Why is this printing in weird order? Do I reuse x in some weird way? Do I shadow it? Oh, no. Oh, this is 3 is 349. So 1 is even, which is well. 2 is odd, and also we need a +1 because it's 3 away. Okay, I think that makes it a little bit better. I think that originally I had this, so I guess technically that was more right. Okay. I mean, this is already too much, so that means something else as well. But we do need 3 of these, so yeah, we do need 3 of these, don't we? Am I writing it wrong? No, this should be right. Oh wait, it's even on the second row, but that means that we always gonna have an extra odd one the way that we wrote it. So my code is wrong, or not even necessary. They're all the extra ones are always odd, at least on upwards. Is that true? Now the extra ones are always odd only if it's a function of array, not even. Okay, fine. So if array mod 2 is 1, then the extra one is always mod odd. Okay, and I assume by logic of symmetry this will apply for the other one, for the bottom. Okay, we're still off by a lot from the brute force situation. Is it the middle? How much does the middle contribute? The middle is too much already, so that means there's still something wrong with this part. Okay, let's see. So this is 66. So yeah, no, I mean the border distance part should be right. Was that is the, yeah, okay. Oh wait, no, I'm off by 1 because 1. Okay, so the 3 tops, but I messed this up. Okay, but we have a pi because I forgot that I handled top specifically. Oh wait, no. These are the inner nodes. So, yeah. No. This is right, but not too right because. Okay. Okay, what am I doing? Okay, so if array is odd, then we do. Okay, so this part seems right. So it's doing 1, 2, and 3 for array. Right? Yeah. Why am I overcounting by so much? And this should be +1 too, so that's why this is a little bit awkward. Is this right? So 1. No. This has to be by 2. I think I took it out for some reason, but. Okay. I mean, we're wrong, but at least we should be more right. Alright, we're undercounting now. Array -2. Is this part true? Oh no, this is times 2 because 1 in each direction. And then divide by 2. But that shouldn't add that much. That adds like 15,000 or something. But the extra one is always even, right? Oh wait, no, it doesn't. But I mean, either way, it's, well, let's see, even, and then if array is odd, then it is odd. Okay, yeah, so this is right. But I mean, now I have to find the missing things. Wait, that's right. Okay, no. Is my math wrong? Why am I off by so much? Off by 20,000. Just for fun, just to see how much it changes the answer. Actually, changes a little bit more than I thought. but still does not account for enough of it though. I mean, this should be right anyway, and array should be right for 500. I need another verification for to see which part of these as well. Right. Wow, I didn't think that just subtract. Now this is okay. This is how many things there are, right? So if x is equal to 1, x is equal to 1, you have 1 divided by 2. Yep, that's right. No, this should be right. I mean, there might be other parts that are wrong, but I feel like now I'm more confident about this per se. Is it wrong going? Maybe I didn't only look at the top and not the bottom. The bottom should be the same, just symmetric. I mean, the comments are wrong, but in fact, we could probably just put it in the same loop. Is that better? I don't know if this is cleaner, to be honest. Now it just looks awkward, but I don't think that would change anything, just make it slightly slower. But just in case there was a bug there. Are these right? I think these are right. I mean, even if I'm off by 1 on these, like it doesn't change anything. Or by enough for me to be like, oh, you know, I guess I should try just in case. But the counting should be right. I mean, even if I'm off by 1 somewhere. Why is this -2? How is this a bigger answer than that? Oh no. No, it's -1. But, well, is it? If array is 3 array, you have 3 pairs. No, it's -2 because you. No. Array doesn't count the borders, Larry. Okay, I think this is the case. I think this is actually more right. Okay, fine. Still off by 10,000 though. Try to find the missing ones. Oh, I guess I don't store the top down. Let's look at just left, right. Is that roughly right? Left and right? Probably. What is that? Yeah, probably. minus 4. No, I mean all the even ones and all the odd ones should be the same. It doesn't matter which thing. I don't think the even and odd makes any difference. It's 131. 17,000. There's only that many cells. There's 3,000 cells in a full one. So why is this only giving me odd and even? It's not matching up correctly, is it? Oh no, this is about right. Okay, I buy it. This is annoying because I feel like I'm close, but I don't know why I'm keep messing it up. Is the way thing wrong? No, it feels right. 500 it is 3. Manual paperwork. How would I even get a 10,000 difference? Like if I were to fudge it and like what can possibly be wrong? It's like that doesn't even do anything because it has to be +2 to do anything, but no idea. I'm trying to think whether that can be any hints. Like I don't even think I'm off by 1 in a way that is helpful. I'm out of things to be off by 1. I feel like I could be wrong. No, I mean I didn't get leaderboard, so I should be able to finish. I have all the process. So away is 3, 2, 2, 2. That's gonna be 1 pair, 2 pair. No, it's gonna be 0 pair, 1 pair, 2 pairs. Yeah, okay. I mean, I'm just trying to simplify some some formula so that I can, I don't know. I mean, this wouldn't help anyway, because this should not maybe slightly, but that is actually surprising. Because the first one is only 1 full pair, so maybe I think that was off by 1 anyway, so I think this is right. Maybe before I was off by 1. Maybe I wasn't that confident. X is 1, if X is 1, there's 0 pairs. If X is 2, and then 3, 2, yeah, I think this is more right. But still not right now. Can I try something smaller to maybe hopefully debug? Yeah, let's try 100 just to see what happens. Okay, so my code is still wrong for 100, but I don't know that, you know, because it's just weird. But maybe we could start with that anyway. Why is that wrong for 100 even though all these other things are 0? So for 100, array is going to be 0. So then a lot of things happen. Border distance is 66. That's a little bit awkward. Oh no, the border distance is 66. Oh, so 100 actually is a good one because it goes over like some of these. So why am I off by 1? Or off by 15? Maybe that helps. This is actually good. I didn't expect that to give me an answer, but I visualized the case, I guess. Well, this is probably... Well, this is right, but it is very awkward. Unless I guess I might as well try that. It's even smaller, but I don't even know. I mean, it could be smaller, but as long as it's right. Alright, let's try this for a second. That is 6597. That is number of evens. So I guess, so that part is still correct. But why am I, most of my 15 going up, down, left, right? So that means there's something wrong with my up, down, left, and right, but it shouldn't be off by that much. Because the for loop stuff is... It's either that or one of my assumptions are wrong. Okay, I mean, at least we have a debugging thing. Debugging thing I can do. So it doesn't call any of these because array is 0. Okay, fine. So it must be top, down, left, right. But which one is it? Zero SY, I mean, that's fine. Also fine, I think. I mean, this looks right. At least in code. But one of these is wrong, or multiple of these could be wrong. Well, off by 15. Why am I off by 15? Am I getting exactly wrong or something? do check this so it's not some weird thing. Everything inside is right. Oh, snaps. I am undercounting. I'm undercounting. Oh, I see. Oh, no. I'm undercounting the diagonal ones. I'm wrong. Okay, I get it. Okay. I'm undercounting the diagonal ones. Okay, okay. I mean, we could figure that out. That's not bad. Okay. Okay. So what do diagonal ones look like? I thought, for some reason, I didn't think it would go far enough. 65. Okay, so because it goes 65 there, but if you're, okay. Okay, so this is going from top and left, and then now this is. I mean, I could do the math, it's just that I'm trying to think. So that the diagonal is going to be the border distance plus another 66. No, 65. Nope. C minus 1. It's a constant, fine. Does that add anything? Not for 100. No, but then what else are you doing it for then? If it's not, no, I mean, maybe this may still be true for my general case, but it doesn't work for the 100 case because now you're going 66 plus 66. You're already out, right? I need to. This is something I need to fix though, but I don't know why I'm missing 15 or 16 or whatever it is. Okay, so there is another bug, so there are at least 2 bugs. I mean, we don't do this. There's nothing in the for loop that matters. So it's only up, down, left, right. I mean, this should be all the same, but I don't know how to debug this. This should be right. Though there is some asymmetry. This one, bottom as well. I did not notice this until now. No, is it wrong? One of these is wrong. I do this twice. This is wrong. Nope. Well, a lot of things are wrong. Alright, so this is inconsistent due to symmetry. But which one? So okay, so top is the last row in the middle. Okay, left is middle, last column. Right is just wrong. There we go. We still have to do the diagonal, I think, but at least that was, wow, I cannot find that bug for the life of me. Okay, yeah. Let's also try 200 real quick. 200 is, oh no, that's not what I expected. Because I expect it to be undercounting, not overcounting, unless I add in something by accident. I don't know. Overcounting is an issue. But that means that the for loop is wrong. But also for 500 is whatever, right? Yeah, 500 is undercounting, but that's because I think we didn't do the diagonal. I expected this to be undercounting, but apparently we're overcounting. So, okay, so this is back to the drawing board once. So this is, was it 66, 197, so 200 is actually only slightly more, so that's actually pretty good for our testing purposes, maybe. Okay, so then now you have array is equal to 1, array is just the number of full boxes length. Okay, so that means that we do one iteration of all these. I assume that the top left bottom right is okay, gonna be right. And then now, okay. So x is equal to 1. We have no full boxes. Okay, that's true. Right, so if I comment these out, it should not affect change. If it does, then we have an issue. Yep, okay, so that is expected. Oh, I think I messed this up. That's why, because for x is equal to 1. No, x is equal to 1 is full boxes. Oh, wait, because if we do left, I'm double counting. No, I'm not. I'm only counting row at a time. Yeah. So then now there's one left, one right. Yeah. This should be right. Or the idea should be right. One left, one right. And then symmetry on the bottom, fine. So that means that this is going from the left and the bottom. So yep, that's right. So one there, one that. I have to double check that I'm going the right way now. And by symmetry, I think we got everything. But clearly, we're doing one thing wrong. Is the border distance different here? Just because we turn? I don't think so. Am I off by 1? No, way more than that. We're only adding... How much would this be? The biggest thing should be this thing, right? Oh wait, no, we always said it doesn't do anything. Where's this again? This is on the middle row. So we have 1 times plus this, which is 15,000 or something, so that's fine. Plus left and right, okay, that's also probably fine. Plus this should be fine. Well, one of these is 7,000, so do I have odd and even wrong? Nope. Or at least it doesn't account for enough of it. I don't think so anyway, but... How am I overcounting? What am I overcounting on? How could I possibly be? Am I? I mean, this. And this form doesn't do anything yet, so it shouldn't be the result. So it has to be these, but I don't. I mean, I was wrong before about these don't do anything, or I was correct. So let's see. So top is going to come from the bottom. Left is yeah. Top and right, okay. Bottom is this, okay. Left and right, okay. We have no idea, but yeah, this is only 20. Is that right? How can it all be off by that much if this is only 20? Alright, I guess we'll have to figure out. That is actually very awkward. Where is the numbers coming from then? What is the contribution? I mean, so it's going to be about 20 for all of these. So that's not the answer, or that's not the overcounting. So where else to go right here? That's just in the middle. That's like 20 as well. So it really is like this thing. But I don't know how. Is this right? How am I off by so much? Only 2,000. Okay, so we only have 4 of these, right? So okay, so we have 1, so there's 1 pair, and that's it. Where's the other numbers coming from? So we have 36,000. We have to this even odd, right? So say we have odd times 4 plus even. It's already most of the contribution. That seems right, right? Am I not getting the odd even right? But even if I just do like, I don't know, even times 5, because they're 5 complete cells anyway, it's still too, like, that's not the issue. The issue is, oh, what is the farthest distance of one of these? So they're not all complete because the distance could be more than. I thought I made an assumption that everything is reachable in 131 steps, but that's not true, is it? Wow, okay, okay. Wow. Alright, BRB, I'm gonna use the bathroom real quick. But I don't know. I mean, I'm just doing thinking anyway, so. How do I do it? This is not that right. Okay, I mean, I think I got it. It's just, I think I got it. I just have to kind of do more calculations. Okay. For example, let's say, how do I want to say it? Say calculate. So this is from the left, and not just border distance, but say 66. This versus an odd one. Yep, I see. So that would account for a good chunk of it. Okay. People on my Discord are just very unhappy with this farm, and I've been just responding. Okay, so there's a border, and then there's another border. I hate you. And then maybe there's a diagonal. I don't even know. I think there might be a diagonal, but so okay. So this is this -1, kind of. Okay. So then now the don't have to type twice. Okay. This is annoying as hell. But I mean, okay. And I don't, and there might still be more. Because this actually just reduces it, and we know that at 500 we have to actually increase more, which is this diagonal thing that I commented out earlier. So this is border distance minus 131. This is just the width. I say width more generically, so it's, yeah. Okay, right. I mean, this is also wrong anyway, that's why. Wait a second. Oh, no, okay. No, this is... Oh, no, this is only on the right, that's why. This is... well, this is going left. No, is that true? No, it's still... The shortest... So if we go left, the shortest path is still top and left, so this is still right. Why am I overcounting by so much now? Oh. Wait. Did I not subtract enough? Should be one less full pair. That's what I have here. I haven't done this part yet. Why is it overcounting by so much? I mean, it was already overcounting, right? Is that why? No, yeah. So I did it. Oh yeah, this part we doesn't do anything yet because x is 0. So we have to remove some stuff. This is on the left. Oh, I guess if this is because this is gonna be 0, right? But then why am I writing it? This is a weird case because this is the top. So there's a top and then there's a top. I see. Okay, fine. But that means that we have to remove one of these from each one. That means we basically count by 2. I think this actually makes it okay, maybe. Okay, but then now we just have to do another one. Okay, so there's only 4 of these. 2. That is annoying. Okay. I mean, this doesn't work for 0, but that's fine, I think. Now we're overcounting. Why are we overcounting? We don't do anything inside, right? Not for 200. Yeah, we don't do anything inside, so why are we overcounting? What did I do? Down left, right, no, and then this is probably wrong now because on this one you have one less pairs. Okay. For 200, this should be right. Right, because the weight loop doesn't do anything. Oh, this is wrong. This is not. Oh, no, it should be right. Top is going from bottom and then add it up. Oh, and then now we have to do the diagonals. Diagonals. Oh, me. It is what it is. I was trying to think about if there's a cleaner way to do it, but this is basic. We have to do this inside as well, but this is the diagonal, and then c minus 1, because I think the closest is actually not for the diagonals. It's not these points anymore. It's actually the one over there. So that means that this is that the same distance? No, it's border distance plus the half, I think. Let's take a look real quick. Does that change anything at all? That does not change anything at all. Huh, that's actually surprising. Oh, it's not border distance plus half. It's the border distance minus width plus half. Okay. And we have 4 of these. I write them in a weird order, but actually easier to write. Off by a little bit. With double counting, how are we double counting? Plus half is not right. It's plus half plus 1. Because you have to. Is it? I don't know. We'll see. Oh no, it's not. Well, I mean, it may be, but maybe I'm off by 1 somewhere as well. Okay. Okay, so this is 66, and then to get to actual 0, it's 65, 66, and then to. Is that the thing? Because basically border distance is the. Okay, I mean border distance I think is right. So now it's on 66, now, which is 0 on the new cell, and then now. Border distance minus width. So then now 66 plus half. Is that just border distance? It turned out? No. They're definitely half closer. I mean, it may be plus 1 or minus 1, but neither of these are right. Is it plus 1 or minus 1? Man, don't tell me they're 2 steps away. This doesn't seem like it would have for this input, except for you. Is there anything that's 2 steps away? Oh no. What is the max distance? Well, that's not quite right. Oops. What do I want? So this, say, what is the max distance here? So it's at least 260. So that is, no, that makes sense. But it's not interior. No way, is it? No, that makes sense because of Manhattan distance. Right? So there's nothing interior that's like crazy looping. I think that's what I wanted to see. Okay, so everything is, so what does that mean? So starting from the middle, there shouldn't be anything crazy. I think that's what that means. So why are we wrong? I mean, we're very close. Maybe now is we're messing up to odd and evens. But that doesn't even make sense because this part kind of works for the smaller number, right? That'd be funny. Oh, jeez. Oh, jeez. Because I don't know. That's just because of how thing though. But okay, so we got it for 200, 500. I mean, we have to do the diagonal things. That's fine. I expected this part. So I have to do the corner. Actually, I guess this is just this. Yeah, I guess we wrote it. Nope. No, that's not true. Oh man, I deleted it. Because these are not corners. That's. Well, these are from the corner. Actually, no, these are right. I think. Yeah, right. Yeah, but isn't it enough? Am I missing some corners? Because I have to do another layer, isn't it? Oh man. This is the problem that never ends. Must be 4. Now you have these. I need to do a checklist. Okay, so let's say we have 500. So we took care of these and these, but we have to take care of these. But then now we also have to take care of these are 2 steps away. I also have to do this is hard to I feel like I don't know which ones have to. Okay, so these are the absolute tops. This is the diagonals on those things, and that's fine. And now I have to do another loop. Maybe this fixes it. I don't know if that's true. Okay. So for one, this is already done, so this. Okay, so this stuff counts the left and the right. I'm having this. I mean, I'm missing something, but it's just I have to keep track. Okay, so we've done all the extra sides, and then now we have all these things, except for the border of these are actually off, and we did the top borders. Maybe for symmetry reason, we'll just move this. Move this here. So the top there's none because we already did it. So there should still be two maybe. And then the second one. We did these two. We thought that, okay, so we did these two, and we thought that these would be complete, but no, it's not. So I think this is. We're undercounting though. That means I have to add more stuff. There's a diagonal here too, but I think I'm just messing it up. I'm kind of confusing diagonals. Okay, so for 500, this is, we did this. This part is this part. Up, left, middle, right, and then these. What are these? I mean, these are the diagonals next to. Okay. Next to the top, but there are two of these. that's right. Well, I mean, there are not two of these for just for n is equal to 5 or whatever it is, 500. Okay, so for x is equal to 1, we have two of these. No, that's fine. Just two. Left and right is, yeah. Okay, I think that's right. I think I'm missing. There is supposed to be some. I think that there are multiple diagonals, and I'm just mixing it up as a result. Okay. Basically, this used to be here, and we're just counting the diagonals. Okay. But then now these are actually one cell in there. Okay, so this actually calculates this. There's two of these. But is the distance correct? Did I get the distance correct? I think the border distance may not be quite this. Oh no, we're doing it from the corner, so that's why. Also the way that I'm doing this well. This is wrong. Because the way to get here is actually through the corner, not the Manhattan distance from the left or the right. That's pretty bad, but border distance minus width possible. Yeah, okay. I want to go back to 200 as a thing. I think we don't change that code in the middle anyway, so maybe that doesn't do anything, because this loop never happens. Let's do 300. Yeah, 500 is fine, I guess. I mean, these are just these two, but I feel like now I'm losing track of what I'm doing. I'm not gonna lie. It's just hella confusing. Okay, now we're connecting on these. Okay. That's better for everything that's not the top down, left, right. Okay, so for array is equal to 3, we did this, we did this, we did this. Okay, and then now we do this. And we also do this, we did this. Is that the right distance? Well, let's see. So here is 66 and this is 66. So this is actually just width away. But man, I thought I was gonna hopefully get a quick one and then go to sleep early, but just grind. The only thing is I know how to do, yeah, like the idea is not hard. It's just so hard to get right. And I knew this going forward, but still underestimated a little bit. What do we have here? I feel like I'm missing one of these, but it's getting increasingly difficult to remember which one I've done. I feel like there is definitely a diagonal missing. This is here on this row then. Well, for the total, but on the second border, if you want to call it that, we have 2 of these, so that's feels right, but I don't know, the distance feels wrong compared to here. But we're under counting, so I think like the distance should be maybe plus width. Okay, let me make sure that my boxes are right. I think this is right. But there's another additional layer that's plus width. I think that's the part that I'm missing. Maybe. How can that be true? Like how can we? There's no way we can't. Oh, this is. Oh, whoops. Double counted that part, maybe that's why. Okay, I was like, that shouldn't go up by that much. In fact, it went up by none. Which is actually maybe expected. I don't know if it's expected anymore, but. Okay, so those diagonals don't do anything, but then. So I thought this. Even one more layer is already kind of confusing as hey. Still checking that I didn't mess up anything too much for. Okay, let's try 300. 300 is already off. Okay, but that's because 262 is whatever is the second thing. Is that? That's already wrong. Okay, but that's kind of interesting. So I mean that allows us in numeric cases because that's 2 times the width. Right. Where is it go to 1? So that means that only this thing changed. Yep, so we need this. Yeah, that's actually interesting. So it was right before. So maybe not. Maybe this is already right. Okay. Huh. 200 and now 300, or which is 263 as we said. Just one more step. We're missing by 8. Which ones are we missing? We're missing 8 corners, I guess. I think that those are the things that I was trying to figure out how to add, but messed up. I think it's in here. Alright, let's try again. Let's just draw this thing. Alright, so, oh, oops. So we have the even. Oh, wait, we have 1 steps. Still. Okay. So we did this up, top, down, left. Oops. Top, down, left, right. And then this part does do. And then this part does think here, 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 and here. Right? What's border length minus width? Border length is 197 minus 131 is 66. Plus half plus 1 is 130. I don't know, do we? Oh wait, no, 132. Half is 65, not 66. Okay, so 132. Where's 132? Okay, so yeah, we did do those. And then we do even. The 8 that we're missing, I see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, I see. It should be part of here. That's the original diagonal, but then I got carried away with 2 distances stuff. So then now, how do I want to do this? This is also just another half distance away, but then is that not just border distance plus 1? Maybe. I guess technically it's not quite, but this should, if correct, add by 1. It does not. Oh, I guess this loop does nothing. That's why. Okay, so what is this? This is this cell. So we want to be able to go half more up from here. Does this add me 1? Nope. It adds me like 1,000. Really? Oh, no, it goes, no. Should be half, maybe +1 if I'm off by 1, but shouldn't be that much higher. Why? Oh, no, it's on the bottom. So then now this is plus width. So then it's this. Did I get it right? Yep, okay. Yes. Oh, there's 8 of these. Why do I'm missing? Okay, so you have this one, and then we only have 4 things. So the other corner, that distance. I mean, the distance is the same for everything, so it's probably just 2 times all of these. Do the symmetry with. But where is this? Oh, I see. Cause okay, I see. Okay, that's great. Okay, now we add another array. This should be wrong because we didn't do this part. And this part we also need plus width. Is that true? That we didn't do anything? Oh. Wait, but does this not do anything? Why does that not do anything? But why doesn't this do anything? Alright, we have to try something funky. Alright. So was it 263? So was it 131 times 3 is 393, right? Let's try 393. Already off by a lot. Let's try 392. When did I change that much? Didn't change anything. Maybe my constants are wrong. This worked, right? Like I didn't make this up. Okay, yeah, for 300 works. 350. 350 is already overcounting. Because it is not 131. It's 131 times 2 plus 65 or 66. 327. Let's try 327. Already too much. 326. 326, right? 327. That is crazy, actually. That 327 actually adds just one more step. adds like 800 positions, but we add like 8,000. Okay. But the reason is that we went from array 1 to array 2. So there is some funkiness here with this formula. What are these supposed to symbolize again? Oh, the except for we moved it there. No, that doesn't make sense though. Does it? Border distance plus the thing is the thing, right? These are the original thingies. Alright, let's comment them out to see how off we were. We're off by a lot. So we definitely need something here. Wait, what? Something feels really off though. Like 51,000 just seems like a upload, but that's because I think a lot of the other things like these get zeroed out as a result, so these have to do more work. Maybe these are wrong. It is definitely very possible. I feel like this is one more than. What does 2 times odd and 2 times even mean anymore? Oh, this is the extra ring. This pairs with these rings for each row. And this is this -1, I think, due to losing another thing. Maybe not, I don't know. I have to do the math again. Okay, so these are the original ones, except for now we're actually a little bit closer. Because my original border distance is kind of wrong. It should be a multiple width actually. So why am I off by 20k? Oh, because no, for each one there's 4. Oh, because I'm missing the diagonal. Because these are the original ones, but these didn't do anything. That's the thing, right? And those are with array. Yeah, these didn't do anything. Definitely not 20,000's worth. And these are the full cells. X is equal to 1, we have none. X is equal to 2, we still have none. So I think this works. X is equal to 3. Oh, X is equal to 3 is really wrong, isn't it? Well, no, I mean, it's, let's see, X is equal to 3, you have still 0, but that's not right. We have 1 pair. Right. But I don't think this changes the answer for what we're looking for. But it is awkward. Yeah, I didn't think that would change, or shouldn't anyway. Because array is equal to 2. Array is equal to 2 means some of these things gets caught, but what? Well, maybe I am missing something like this. No, that didn't do anything. It's basically what are these cells? These cells are those cells. And then we wanted to say we want to stretch one more. I don't get how our counting went down. All right, let's see. 326 of 91,000, and then our math is just so bad. 327 we go down because array is equal to 2 instead of 1. And the border distance went up, which is fine. Because the top-down left right is not counting enough of it, or at least this is not making up for the loss of these due to some off by whatever errors. Oh man, now we're gonna solve this one. No, this is wrong on a copy and paste. But it's actually pretty bad, but oh well. Doesn't make up for 20,000 though. In fact, it alright, array is equal to 2. So then now we have exactly this. Just draw it out. I have to draw it out because I feel like I am having poor visualization skills. Sad thing is I got this so quickly, like the ideas, but I just cannot get the coding right. Okay, so then now we have top down left right. What does the top down left right mean? Top down left right means crossing things out manually. Alright, and then you have these things, which is this, 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 and this. And now the diagonals. So for array 1 and 2, so for array 1, we go here, so that's that, and that, and that, and that, that, and that, that, and that. Okay, I mean, is that what I did? Okay, for array is equal to 1. This should be actually from 2. No, this makes sense. Well, it's this one, but then these two, these one makes sense, but this loop, it's a little bit weird. No, I guess it looks at the previous one, but it's a little bit confusing to say. Fine, fine. No, okay, fine. I think I buy it. There's one, there's two. I'm missing one copy of these for the medium roads. Okay. And of course you could have just like do the math on these, but I don't know. Like you can actually count all these, but I feel like for loops are easier for me. Okay, these that did nothing. Maybe just off by, okay, well, let's continue counting then. Now, how many pairs do we have on mode 2? We have one pair. Mode 3, we have one pair. Do we know? I'm still losing track of everything. Why these 2 times? Because this is on the previous row, that's right. No, what? No, you just fudged it, Larry, I think. Let's go back a sec. Is it like 262? Yeah, 263 is already wrong. That may be just because I added a bunch of stuff though. Honestly. Yeah, so this is still right. Okay. But it may be because I did it in a weird way. Okay. Yeah, I just cheated in a weird way, that's why. Was it 3? Well, I don't remember the number anymore. Okay, and like, was it 330s? 3 or something? Binary search. That is great. And then as soon as we get to array is equal to 2, how though? How are we losing things? Because the border, these are returning smaller numbers because of the border distance increase. Maybe this is one. This is right, we have to add in back in some stuff. That's not going to be enough. I know it's not exact, but it doesn't give me. That's the toughest part, is knowing what to do, but I'm not doing it. My code is a mess, maybe. Okay, let's actually count it out. All right, let's do it again. Okay. Instead of writing all this iteration code. Okay, so now we have 2 away. 2, 2, 1, 2. Literally drawing everything. Right? How many? Okay, so I'm going to start labeling these. This is a 3, 3, 3, 3, right? So that's a 3, that's a 3. Okay, right? I need some 4s as well, maybe. Right, so then now, how many 3s are there? So for each corner, there's going to be a array number of 3s. This way. All right, let's go. No. Okay. Maybe that's what I should have done in the beginning. But okay. And then now we're dealing with. Oh, I know this isn't right. Because they're different distances. And also, yeah. Oops. So this is coming from. So this is the top left quadrant. So that means corner is R minus 1, C minus 1. The distance is these are still 3s. The distance is slightly closer. It's border distance minus width plus half plus 1. That's this one. And then you have 4 of these. Okay. Yeah, whatever, I could rewrite these. Maybe not those. Yeah, okay, I'll just keep it for now. Okay, and then now the twos. The twos are still not complete, right? So the twos, top two, just this thing. I guess I can copy and paste and move it here. The two distances away. Okay, top, down, left, right. So we go with this. So then now the diagonals are going to be away -1. Is that right? Maybe I just had it wrong. Maybe this I could put in a folder, but and then everything else interior is going to be odds and even things. I'm too lazy to do the math on this one, so maybe this will make sense of it. Do we do all the twos? Bottom left, right? Yep. So then now, let's count from 0 to away -1. So now we're doing a different formula. Top, what? Oh, yeah, okay, we do it twice. So for row X, there's going to be the way I did this is a little bit weird too, but okay. But yeah, so okay, the entire row consists of array minus, wait, what? So row 0 is going to be array -1 times 2 plus 1. Right, that's the number of cells. And then, yeah, this is always odd. So then now pairs is going to be equal to half of this. And then total is just equal to odd times even times or plus evens times pairs. And then you have this thing afterwards. I think this is wrong. But maybe. Yeah, it's very wrong. I mean, I thought I would be off, but I didn't think I'll be off by this much. Did I mess this up? Oh, it should be array -1 inclusive, so that's why. Okay. Okay, let me check for a smaller number. We overcounted. No. So that this part is now a little bit different. No. Oh. Wait, what? How do we overcount? Because this is supposed to be this times 2. Because for a top and bottom. Maybe this was right. Oh, yeah. 0, 1. No. This is more right below beyond the counting because we didn't count the straight across one, which is what this is for, I think. The middle one. Alright, not enough to fix it though, but oh, this is also just wrong. Yeah, that's kind of backwards. Okay, I thought they would be equivalent. That's all. I mean, we're missing something, but what? Let's go back to 200, just to make sure. Okay, 200 works. What was the thing? What was the border that we did? 200. Okay, so this is where we're missing the 8 things. Because now we're widths away, and then now you have to do an extra diagonal thing. Which ones am I missing though? Oh, these 4s. Is this right? 3s. Isn't this like times 2 or something? I'm missing a times 2. Definitely not in there, but off by 8 again. Which ones am I missing? Oh, let's draw a different one for 262. So the way is going to be 1. Never gonna get this. Too many places to be wrong. Missing 8. But which 8? Alright, so for this one, array is equal to 1. Fine. I have these things, but I don't know what they mean anymore. So border distance 197, is that right? For array of 1, I think that's right. So then that's, so these 4, even though they're labeled as 3s, got rid of these. And then here, array is 1. So we do get rid of these. So that's actually accurate so far. And then now, we get the top middle. Okay, fine. And then these things are just zeros, which is maybe fine. There should be a way, not. Give me 4. Okay. Okay. Okay, so we lose a lot somehow by going to array is equal to 3 because we're missing something, missing. Why though? I guess we're missing the 4s, but I think these are the 4s. Let's redraw this. Okay, so the top, down, left, right. These are all the 3s. So this one, this one, this one, this one. Array is 2, so yeah, that makes sense. Okay, top 2. Okay, and middle, and bottom. Okay. I think this is a fudge factor. This makes no sense in context, to be honest. These are not 2s, or at least like the 2 different things. Also, these are already zeros. So this doesn't change anything. It's just that these things. Oops. wrong in some. No, that means that I'm completing these ones wrong. Maybe. Like what is the effect of this? Okay, well that's just too big, but now for way 0 to 2 you have 0 and 1, which is fine. Actually, this is a little bit too much. You should start at 1 even, maybe. Yeah, this was really wrong, huh? Is this still right for 300? How do we get it right for 300? Oh, yeah, I guess it's still right for 300, so that's fine. Because doesn't look right. I think this is double counting some stuff. Okay. $326. We still right? We still right? Oh yeah. $327. We became sad. How now? Oops. What the? How did I make the same? What is going on here? What is happening to my buffer? $928. Okay, I mean that makes sense. It just means that we have one more full cell to deal with, right? Which should be taken into account here. But it's not for some reason, is it? Okay, so this is wrong as why, because this doesn't do anything for some reason. Okay, so we know the part of the code that's wrong. That's good. Why though? This is basically the number of so for array is equal to 2, you have one row, right? So this should be right. Maybe I just had off by 1. I mean, it's wrong, but it should be right. Okay, that's still right. I just want to double check. Okay, so I mean, we're maybe overcounting, but don't tell me we need another layer. That would be really nasty. what is it, 327? So 66. Now you should be able to go for an entire cell. So it's either that or we just do this, but that doesn't even make sense because it's not off by that much. I mean, this changes down to like 60, but do we always overcount? Yeah, we do always overcount, though overcount by less, so that's actually not a good sign. Possibly. Okay, so 0, 0. Should be always zeros, but it's just that this adds an extra odd or even or whatever. May also be this part, I guess. Alright, so oh, this is definitely wrong. This is the number of pairs. Because basically array, no, if it's 2, no, it's minus, no, this is right, surprisingly. Array is 2, you have, okay, so you have 1 pair. And then you add stuff, but how is this wrong? What am I missing? That is by 81,000. 81,000 is off by 11,000. It's like a full cell. Which cells am I missing? Yeah, am I still going down from 326? Yeah, okay, so there is something more fundamentally wrong here. Why am I missing cells? I don't know if this is part of this right either. These are the 2s. So these are basically zeros. Is that right? Maybe that's not right. Maybe that is right. So, because one width away, how am I missing by so much though? Like this is not missing by a little. Missing by 11,000 is literally another cell and a half. I have one row, but this doesn't even make sense. This doesn't make sense either. Oh man. First of all, you have one. You have one pair. Which is not true. Somehow that's still right. Okay, fine. So that means, yeah. How does going away? Okay, so basically it's because how does one at 6,000, you have two at 9,000, but we have to add some completes. What are our completes? You have one no completes. You have 0 completes. No, I mean definitely it's still pairs of completes. So the way is 2, you have 1 pair, right? What is this? I think I'm just like messing around because I'm just so lost right now. How can why is my function not monotonically increasing? This is not order components, or like they're not even accurate, but I just want to order magnitude. Or order for contributions. Okay, so going from 1 to 2. Am I doing the math right? Let me double check. 326, so that means that this is 66. And another 131 is 190. Whatever. 197. And then 326 maybe? Actually, let's double check. Yeah, 327 is the border. So, I think I print that out, right? $328 is the border. So 327 is the why is 328 then? Maybe I'm off by 1. That'd be fun if I was off by 1, but I don't think that changes things. I mean, fix this thing, but then, like, it just means... So that would be funny if that's why. But no, it just shifts the thing 1 more. Right? So maybe... Okay, yeah, this is when it starts being wrong, so that's good. Maybe I was off by 1. But I don't know if I'm off by 1. But still though. We have 4 of these at 7,000. Where is the answer coming from? These are zeros. What did they used to be? Used to be 1000, but that doesn't even factor in all the things. They're much smaller. Sure. But that means that I have more completes, right? I guess I just have to factor. Something like this, right? So we have 5 complete squares, which is 1 complete square to 5 complete squares. That is actually right. So where are we losing so much stuff? Well, something's off. So we have 5 complete squares, that's fine. But the 2s are, even though they're not complete, they're mostly complete. Like this should be, maybe this as well. These are not 2s, that's why. These are 4s. I'm missing the 2s, the diagonals, and are almost complete. That's where I guess I had another fold up earlier. What's the distance here? Is 66 plus 66, so it's just 1 width. In terms of border distance, it is border distance minus width. No, it's this part though, right? It's just that these are returning. Wait, what are these? I am tired. $263. What's 263 again? Oh, that's the length. Is that 263? I mean, there are some 263s, but I think the one that I'm thinking of is actually closer. So, and maybe that's why. guess I was missing one, but it just took me so hard to find it. Right, don't do that. Don't do that one for testing. But I guess I can do like a few more cases first for the brute force. Okay. So then now, what's this? Oh no, I'm too high. That's what I was afraid of. I mean, we used... Oh, let's try another one, but with an odd number. Maybe I have an off by one with odds and evens or something. No, I mean, for 1001 is right. So why would I be too high? Tell me why. I don't need these anymore. That should really cut down the right code. 5,000? This is already going to take a while. Let me time it real quick. Maybe 5,000 is too much already. It works for 1,000. If it works for 1,000, what can it go wrong with more than 1,000? Alright, 5,000 is clearly too much. In fact, maybe even crash my computer too much. 2,000? Okay, 2,000 we're actually off. What works for 1,000 and not 2,000? That is crazy. I am overcounting, but what can possibly... Do I have to do a binary search? Yeah. Alright, it doesn't work. But what? It worked for 1,000. What does have to... Do I have some constants by accident? Oh, maybe. I worked for 1,300. So we have 10 of these or something? What? Do I have some weird constants? Like, I don't think I do anything that's specific. Wait, 1,300 works, right? Yes. 1,400. And then after that it gets exponentially, well, maybe not exponentially, but just much slower anyway. Works for 1,400, but not 1,500. I'm trying to figure out like what is special about the number in which I start failing. Okay, so this fails, so we have to go smaller. This is hilarious though. So there is some binary search after bisection. Alright. Maybe there's something weird. Why am I overcounting though? How am I overcounting? That is wild. Okay. if you're watching this, I don't know why. I appreciate that. I'm not trying to hate. I wouldn't watch this. But, you know, maybe we'll skip to the end, and maybe the end is a happy end. Alright. What is so special about this number that makes me overcount? What is so special about this number? Odd, even. Do I mess up odd and even? Away and border distance. So it's 10 away. Border distance is 1376. So he's not even. Wait. Border distance plus something like that maybe. Oh, not width, plus half. Just, I don't know. I know. So 1442. So that means that we're at the border again. I did have a weird -1 factor that I wasn't sure about, but maybe I just have to remove it. Nope, that doesn't change anything. Huh. How am I overcounting? Undercounting I can understand. Overcounting? Okay, so this is correct, and then just want to make sure that this is monotonically incorrect. No, it still is overcount. Still overcount. So it's not just like an off by 1 on the edge thing. Or maybe it still is, but overcount by a bit. Huh. I mean, it is exactly on the border of this width thing. So so this is the first wrong number. Let's see if I can generalize for something smaller. Why does this take so long for 327? Did I not save? I mean, I didn't save. Alright, okay. Is it the same thing again? Would I have to do more layers? That doesn't make sense. I can't see how that could make sense. But we have eliminated all the other possibilities. Possibly. What is so crazy about 10 distances away? I thought we were done. How are we overcoming by 36? Like, even if it's off by one somewhere. I mean, what I'm worried about is that we're overcounting this, and then we'll do this. Which maybe is fine, to be honest. I think I know enough to generalize it a little bit. Alright. Let's make a copy of it. Alright. Right. Oh, no, that's fine. Oh, whoops. Nope, just what did I paste? Probably just this, but this is overcounting. We have a better case for overcounting anyway, but oh yeah, what I wanted to see is to see the array steps. Nope, that's not it. This is it. Right. Yeah. That is a big number to loop over. I mean, even now it takes 1 second, and I only have one loop. So basically, I would just parameterize this thing, but well, I mean, you don't have to. Should only be a few layers, but maybe I'm wrong. Okay, well, let's rewrite this. The trees. equal for away is equal to 2. I also group them together in a weird way, I think. Maybe not, but they're now in the same row. This should be on the same row. Right. Alright, we'll do the optimization after this, but we'll see if this works first. We can just go back to like 300 real quick, because we probably, this is way too high anyway. What am I overcounting? I mean, that works. And then it doesn't. I got 50 right by accident, I guess. 65 is exactly a half a width away. I didn't think so. But why are we only counting then? Oh, I see why it works just randomly. What am I undercounting? I see, I weigh 0, so okay. So this is just basically one cell, 0. We add a bunch here, which is probably what happens, but then we don't loop here, or we do loop there actually. Huh, that actually is pretty close. But go off by a little bit. That's nothing. 65, so then go 64 to 65, 64 to 65. We went from away -1 to away -0. So that means that this executes once, but all these return 0. Oh, I forgot to add the completed stuff. Do I though? It's not the completed stuff. Well, kind of is. Why is this returning 0? from the bottom. Maybe returning 0 is right actually. Oh, I have an off by 1 maybe on the MX thing, which I kind of fixed, but maybe I wasn't sure about this one. Okay. I mean, still not gonna be right, but yeah, still a little bit undercounting. Let's see, 65 cells away. 66 should be, yeah, 66 should be the border of new stuff. And I add 4. But in actuality, it adds a lot more. How? How is the odd even thing? I think that's why. There's no completed square. Actually, I do print even out of way, so odd even went up, but so at away is equal to 0. Yeah, this is not worth debugging. We don't have to solve it for that case. Okay, now it's overcounting. So double check my backup. Maybe I should use source control of it. I can see how we're double counting now. Okay, so for 200, we have 1 completed cell in each one. So then now we have 1 of these. We handle it. We handle these. This array loop is a little bit weird, but there's not a way amount of these though. It's like a way minus x or something weird. Okay, so there's always going to be right? So then now Okay, let me renumber these with X. Let me say we have 0, 0, 0, 0. Always have one of these, and then now 1, 1. Now you have 0, 0, 0, 0, and that is just array minus 1, minus x minus 1 maybe, plus 1 maybe. I don't know if the plus 1 is necessary, but okay, so I think a minus 1 to be honest, but okay. I think one thing I want to try is see if this is fast enough. Because if it's not fast enough, it doesn't even matter if we do it, if we solve it this way. But the way we write is 200,000 times 8. Not ideal, but it's actually not that fast either though. Well, after a while, these you don't have to calculate a lot of these because they just become filled, but with some odd even thing, maybe, possibly. And that's if you think so, Larry, then let's try to do it. Plus half is the same distance, but you only have you have 2 of these per row. I think this is right. But maybe I'm just doing some other things wrong. So for x is equal to 0, we have so for y is equal to 2, you have 1 of these. Okay, so let's say y is equal to 2. Calculate the 3. That's fine. And then you have 2 of them. So I think this is right. It's like a plus 1 minus 1 thing. Then why am I undercounting? by so much. Is it the odd even thing? Yeah, I guess I don't do the odd even thing anymore. Well, I mean, I guess it's here, but is that even right though? Do I need to do this? In theory, not. But how am I undercounting though? Yeah. Isn't this the same code, or should be around the same code? What did I miss? Should I do this? So 0 and 1. So 0. Yeah, so just minus with. Maybe without this. I think that's not quite right for the interior ones, but yeah, I don't think this is quite right for the interior ones. Maybe it is right. Maybe I'm just overcounting the really middle cells, the last layer. Oh, this is not necessary anymore, I don't think, because we actually do take account of the thing already. Maybe just we double count this in a weird way. Now this is definitely whatever, but how do we undercount though? What are we missing? If I expand this out, so for array is equal to 2. I mean, I know that this is a -1, and there's a weird ×2. Oh, there's no ×2 anymore, the way that I'm writing it. Maybe that's why. Well, these are zeros apparently. Alright, so if I match that for 200, okay. Alright, now the moment of truth, the number that failed us before. Oh no, we're still off by 38. How? This is pretty, I mean, I wouldn't say this is very brute force, but this is as brute force as you can do it. And we still have the same issue as before, except for it's much slower. It's not that much slower, it's a little bit slower. Huh, now we have an undercount. That's actually interesting. Maybe I'm just off by 1 because of the weird mx -1 thing. What is so special about this number? I mean, I know it's on the border of the 10th block. Alright, it actually fails earlier than this, so it's not quite right. Because I'm undercounting? Okay. I was hopeful that, how do I undercount though? That is so wild. Yeah, 1300 works, but somehow... Why does my code only work for small cases? And now it's undercounting. And I don't even think this runs for fast enough. Oh well, maybe it could be actually, but still. Times that by 100, at least. Why am I undercounting then? This is the most frustrating problem because I feel like I know how to do it, and I just don't know how to actually do, like I know the algo. And we got the thing pretty quickly, but I just couldn't grind it out. Like I got all the logic. Does this change anything? Nope. Why? How am I undercounting? Is there like a weird example that I'm not thinking of? Am I running out of memory or something weird? How am I undercounting? Man, I've been 4 hours into this far. Huh. Actually surprising that that worked. Maybe it's like 131, 170, 1376 or something like this. It's another magic constant. Yeah. But why, Tommy? Why? What is so weird about having 10 copies of this? Because this has failed me in 2 times. Is there something wrong with... And this is Python, there's no overflow, there's nothing too weird. Does the cache actually work? I am curious whether I... I thought this would work, actually. Maybe it'll be something I'll look into once I get the actual answer correct. Why? What is so different? What can possibly be different? I don't get it. Like I honestly do not, other than minus like some weird typo thing that I had, but how can it be right for so many inputs and not be right for... And I solved it in 2 ways? Kind of. I mean, I didn't solve in 2 ways. I attempted in 2 ways. And it works for all intermediate ones and not just... Okay, no. This is wrong for other stuff too. Just that... Oops, let's try. This is good actually. Okay. It works for certain numbers, but not others. 21. Well, okay, let's say 131 is the full cycle, so let's say anything over 200. Because I think I didn't really include the thing that well, but what's it? 196 to 195. Okay, but that's because we now have 1 full array thing, so then you can chunk it. Okay, but then what is 327 or something is? The low numbers being incorrect actually I expect, because we don't special case. Ooh. So, okay, this is good. This means that I may have an off by 1 somewhere. I go from undercounting to overcounting is kind of concerning. And then undercounting again. And then overcounting again. Is there is this part right? Oh no, I see. Because the middle number is always even. But in the new way that we've been doing it. How does that even work half the time then? Okay. Okay, so that works. Let's try 1500. Well, these are all even numbers, so I guess I should try the odd number. What's my input anyway? My input is an odd number, so I guess it's worth trying that. Just in case I... Yeah, that is a very silly bug left over from previous rewritings. Okay, that's good. Let's try 2001. Just... I don't know. Am I stalling? Maybe a little bit. I'm tired, but... I am also curious before I run it for real big, because this is clearly also takes a while. I wonder if my thing is caching though. It takes 15 seconds, but that's with the brute force. Without the brute force, it is 1 second. But we want, that is a lot more digits. 10,000 times faster, slower is not going to be cutting it. I want to make sure that I am caching though. I actually don't know. I think that's how I cache a list of it. Maybe I am weird. But I guess I can also just turn into a tuple. maybe not. Let's say should not do this for whatever, but it should be array number of times. So 122 is not good. That means it's not caching. No, that's not true. It could be 8 times that. So yeah, because we do call like 8 times for each thingy. What's it? 14 times. Yeah, 14 times 8 is 112, and we probably do a couple more funky things like here and here. Just running real quick. $12 seconds for. Yeah, I mean this seems like it's caching, but I think we can now figure out how to skip some stuff, which is what I wanted to do. With SD. Okay, yeah. But then now we have to count whether they are full squares. How do I do that? The starting distant parity. Okay, fine. If total is equal to even. So check. I'm just taking it very slowly now. Okay, so these are the things that we can cache, because that means that they're already equal to even. So that means that we could cache going forward, and we can cache going forward because we're going progressively slower anyway, or the diminishing thing. So that means that if totally equal to even, best of start mod 2 is equal to even. Something like that, and then maybe like a memo on a memo, kind of. This is giving me the same answers before. Let's double check that. And this is for, let's double check that for a smaller number. Uh, 70, 71 something. That's wrong. So I have to still be a little bit careful. Is it an auto operation thing or? We still overcount. Why do we overcount? One cell is full. They have the corner. About the same corners. I know this will work, but maybe not. Do something funky like this. It reduces the collusion a little bit, but still, I think this will work. I have to figure out how to not do work on the duplicates, but actually. How long does it take for 2 seconds for 3000? What are we trying to get to? Oh yeah, this is no way this is gonna work. How do I cache this in a good way? When I cache this, it's still kind of slow to be honest, but even that as well, huh? So you can't really cache any. Why not though? Given the same start, am I not doing these in order? They should be in decreasing order. Oh, this is in decreasing order. The only thing that could be different is just the parity, right? Like if it's full, why would futures not be full? Okay, let's check. Oh, I am dumb. Okay, maybe it does work. But this is very silly. I mean, I'm 5 hours in, so you might have to cut me some slack. I couldn't figure out why. Okay, there we go. Now it's cached. Is it fast enough? No, actually, that is pretty fast. Okay, I'm confident that I can at least run it. This is the same answer as before, isn't it? I'm gonna try again, just in case I messed up. I had this answer! Did I submit the wrong number or something? I have to look for my tapes. That means this code is right? Because I had... I don't know. Did I copy and paste the wrong input? Or something? I don't get it. How? But no, mine was too high, right? I don't know what happened. Also, I don't know why this is faster not during the test example, but that's besides the point. We made that back up at least an hour ago. I have to review, I mean, I don't know anymore. I have to review my tapes. This was how Phil did it in an hour. So I mean, this was a very hard one, but just to kind of get it right, I don't even think it was that hard in understanding once you realize the trick. I don't know what happened. I have to really look at my tapes. Actually, I mean, I don't know if you're still watching this. Why would anyone be watching this? But this is already 4.5 hours in, so I might as well take a look. What did I do? Did I make some changes? I'm going to just look at the tape. When did I submit? I mean, I'm just looking at the video. Okay, so we did fix this. Okay, that looks good, but okay, so that's when I submitted. It was the wrong number, but I don't know how I got that number. But I was overcounting. This is why you always save your values of what you submit. Or I would have tried it at least a while ago. Is it because this doesn't work? I guess that's why. My code didn't work for an edge case, but worked for the. Well, so I fixed it for the actual example, but not the edge case. I guess technically my new code is more correct, but still. Oh my. Yeah. Oh, I wanted to time it. I mean, 2 seconds is fine. I don't know. All right. Could I have done it faster? I don't think I could have done it. I mean, I didn't think I needed to do it this way, but I think I was just a little bit lazy. Not lazy, but maybe. I mean, I definitely prematurely optimized. Maybe that's the thing. But this wasn't even necessary, per se. You needed 2 layers deep, but which I had manually unrolled. All right. Let's go over this problem really quickly. I don't know who's watching this. If you're watching this, leave a comment in the comments. I'm just curious who is watching the end of a 5-hour video. But part 1, what is part 1? Part 1 is just breadth search, I think, right? Now, this is the part where I was like, oh, I wish I got it quicker, but I had a silly mistake on part 1. I don't know if I would have gotten it. Let's see. How long did it take me to... Yeah, just I'm curious. To debug. So... So 522 on this thing. So oh no, that's already deleted. When did I say it was? Alright. Oh yeah, I did a +1 too, but so 506, something like this. Oh, that's at least a minute. So I spent only a minute 6. I only spent about a minute on debugging, which actually, where was my stats? I don't even know how to get to my stats. Oh. Yeah, so 1 minute I would have gotten. Oh, where's the? So many different leaderboards. It's so hard. So if I did in 416, I would have been 65th or so. Give or take. So that was my opportunity to get some points, but oh well. Okay, and part 1 was breakfast search. I'm not gonna go over too much. It's 5 a.m. friends, so but I will go over part 2. Part 2 is kind of shenanigans. I mean, whether you like it or not, if you're doing it, you're doing it. If you're not doing it, you're not doing it. That's up to you. Because you know, like at the end of the day, you get to choose how you spend your time, and that's what it is, right? And you look at the input, and one thing that I noticed, where's the S? Oh yeah, no, is that the row is all dots. S is directly in the middle, and also you can't see it easily, but all the columns are dots, right? So basically here, oh, I have my painting thing on. Hang on. So basically, you have. Let me just do my real quick. Sorry, friends. Yeah. So you let me draw a smaller square. So basically, you start with something like this. You have an X in the middle with a start, and you have perfect lines going up, left, right, down. And this took me a while to kind of realize as well, because I was going to do something like combine the edges, yeah. Well, let me go over the way that I end up doing it. Is that okay? So in this case, well, what happens, right? That means that there is a shortest path to a lot of these things that you can do with math instead of just directly calculating a breadth first search. And what I mean by that is, okay, now you erase this. Now you have some, oops. You have some smaller rectangles. Say, you have all these things together. Let me just copy and paste real quick. Hang on. I mean, these aren't even rectangles, but okay, fine. All right, I don't know why I drew it this way. Let's just write a big thing and then just draw boxes, right? I am not smart. Oh, right. And then now you have same. Yeah, this is a lot of lines. I didn't think this through. There'll be fewer vertical lines. There'll be fat squares. All right, so something like this. I mean, pretend I drew better and less rushed. Okay. Did I draw even number? I did draw them. Whatever. So let's say your S is here. Then, because you have a highway, if you will, then you know the distances from here to this one, which is the lower left cell, this one, and so forth, right? Because this is just Manhattan distance. And of course, you can also, so then now the idea here is just doing a breadth first search from here and try to fill out this square. And then you do the same for every cell. So every cell there's only 8 orientations, right? So if you have one cell, try and make it a little bit more square. One cell, then you have 8 places to start from. You have here, 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 here. Oh, whoops, that's not true. Whoops, sorry, friends. So you have these 8 corners to start, or 4 corners and 4 the edges on the highway. And basically the idea here is that each cell, the shortest path into that cell will be one of these 8 points. And then, so that's observation 1, right? When you have a highway. So when you have a highway, you have to do that. And then the thing is that, so the first thing you may notice is that, a lot of these cells are full, right? So I'm going to color these in, not black and white because I always use black a little bit, but maybe green and blue, maybe? I don't know, right? So in a way, this is a checkerboard thing, right? You get what checkerboards are like. I don't know. I guess green and white is fine too. Right? And what that means is that when you get here to one of these, it doesn't matter which one, if you fill all this within one square, it matters if you start on an even parity or an odd parity. And of course, odd even parity, you could just say also the color of the box if you want to color them in a 2-colorable kind of way, right? And so you have to kind of keep that in mind as well. But otherwise, then now you can just do some maths, right? The first thing that you may notice is that, let's say you have, I'm using round numbers, these are not my numbers, or even probably not your numbers. Let's say that you have you have to do 1,000 steps, and each cell is 10 width away. Then that means that you're going up 100 boxes, right? So let's just say there's 100 boxes or cells or whatever. And of course, you may say that 99 of them is going to be full. So because this is going to be full. Because it's too close, this is going to be full, this is going to be full, ... all the way through. But it turns out that and if you kind of follow this logic through, then all you have to do is do stuff for what we would say the frontier, right? So here's a frontier box. I don't know why I drew it outside the box, but yeah. So then here, you would say maybe frontier, maybe the border, whatever. I'm going to use another color. Let's just say here. And then now you have this diamond E shape of the border. It turns out that, of course, and for this box, sorry, drawing is hard, especially at my fingers here. For this box, for example, the distance between S to here, from the bottom, from this cell, right? In this cell, you could just calculate the math and then do a breadth first search. And then here, for example, it is just, move this a little. Here it is just, well, you're starting from here, so that means that this is this cell. But it turns out that if you do the math, every one of these diagonals, my diagonals are poor, but yeah, every one of these diagonals uses the same corner. Maybe not this one. This is a left, right? But all these other diagonals uses the same corner, and that corner actually is the same distance because it is just the Manhattan distance, right? x plus y, dx plus dy, and then dx plus dy doesn't change in this case. Dx change, dy change, but dx plus dy does not change. So actually, you could calculate all of these, or you could just count the number of things and multiply them, right? So that's basically the idea here. Yeah. However, this is not right. Why is this not right? Because inside one box, it is not Manhattan distance. So because it's not Manhattan distance between one box, there are actually an edge case, which tripped me up for a long time, but just on debugging. And I don't know, I drew so many diagrams. But basically, for example, you can say that within one cell, maybe you have some way, let's just say from here, there may be some way you can kind of go like some weird, you can imagine some weird spiral thing. I mean, not to scale, but you imagine like this one is really, really far, and actually you cannot get to it even 2 steps away. So that's basically the idea here, is that, okay, well, now you have to kind of calculate stuff that is 2 steps away from the border. And it turns out, I think, for my input anyway, so maybe yours may vary, that for 2 steps away, it should be good enough, but you don't even need to do that. Or you don't have to make that assumption, but I think that assumption is enough, and that was my first attempt. Though for some reason, I didn't submit that answer, or I submitted another answer that was incorrect after I fixed it. But yeah, but you can also notice that, all these are the same, right? So now, all you have to do is basically iterate on things that are one thing from the border, things that are 2 things from the border, 3 ... And of course, if you have 200,000, or in my case, I had 200,000 cells before this is the case. And of course, if you just do the math, 200,000, we have to run it 2,000 times 8, because one for each orientation. But you have to also times the cost of each breadth first search, which is like 131 square. It ends up being like 32 billion or something, right? So that's still too slow, so you have to do one more optimization if you do it my way. The optimization is going back to the 4, or what you said earlier, which is that at a certain point, and it turns out it should be 2, but maybe it's a little bit weird depending on some edge cases. Yeah, but basically, if, for example, if this one is full, then every other one under it is going to be full, right? For obvious reasons, because if this is full, then this is going to be full, then this is going to be full, then this is going to be full. Of course, you have to take account the odd evenness, etc., etc. But that's basically what this means. And by the same logic, if this is full, well, this is full too, but you don't even have to. Actually, I guess you should care about it a little bit. But either way, but this also means that if this is full and this is full, then this is also going to be full, but this is also going to be full, ... right? So in that case, you can make an optimization, a branch, a shortcut to terminate early and just return what you would get if it's full. And with all that said, we'll go over my code really quickly. I'm not super proud of it, but but I think let me actually take a look. I'm not going to refactor it anyway because it's 5:10 a.m. and I am tired. But yeah. Okay. So I'm gonna go over part 2. This is direction. Ooh. Direction. I set it up this way so that I can do a cache very lazily. We cache on you could just tuple an array and then make it cached. And I just want to make sure that cache. That's why this chord thing here. Yeah, and then this is basically we input the starting coordinates, which is one of the 8 places that we talked about on the highway, if you want to call it that, and then the starting distance. This is the memorization on priority. Basically, this is we'll go over this in a little bit, but the rest of it should be pretty straightforward. Breadth first search. We start all the breadth first search cell in the same way. The reason why I have this is because there are originally, the reason why I had this was that originally, and I was wrong about this, is that I thought you would always come on the highway instead of the corner, but the corner is actually the more optimal place, and that's why I had an issue with that in the beginning. But yeah, yeah, you set all the starting point as the distance, and then you just kind of do it brute force, keeping in mind the max constraint that you're given, and yeah, and then at the end count that. And oh yeah, I think one of the things about part one is that if the parity is, like I said, if it's an odd evenness, so it becomes the shortest path. You know, you may say, oh, but it's the shortest path. How does the shortest path relate to exact number of steps? Well, because this is a grid. There's this, like, you can think about this as a chessboard, right? With black and white on every alternating color. If you're on black, you can always go to black every 2 steps. If you're on white, and you can also change, right? So that means that if you want to go 5 steps, like if you want to count exactly 5 steps away, if something is, so everything that's less than 5 steps away, let's say 3 steps away, you can just go to 3 and then kind of, hop back and forth to get to 3 because you have 5 steps. So it becomes all the shortest paths that are 5 or less with the same parity being odds or evens, right? So that's basically the other trick that I have to, there's so many tricks on this one. Maybe there's an easier way and we'll read it up, but this is the way that I did it. And it's very sad. But yeah. And then this is basically my way of doing a second memorization. Basically, this is saying, it's not a memorization per se, but this is just saying that if this is true going forward, like, because basically there are only 2 pairs. If this is either even or odd, that means that going forward, everything from that starting point, and the way that I count it is going inwards, because we're going inwards, so everything going forwards or inwards is going to have this number, either even or odd. So we kind of put it in a second cached, and then the second cache we just return it when we need to. Yeah, and this is the for loop. Some of these is math, so this we calculate the full, and it doesn't really matter where, but yeah, because if you hit every cell, that's basically what this does. So you just calculate from the beginning, or from the middle of the square, the odd thing as well. But yeah, this is just the width and half the width, and this is I don't know why I called it away. I think I just called the number of cells away, but it is basically the number of full cells that you get to use. This is the border distance. You could kind of do the Manhattan distance math to calculate this. And here, this is just up, down, left, right, and then basically the 8 diagonals here. The up, down, left, right only appears once, because you're going straight up, straight down, straight left, straight right. I didn't do the direction. And then the diagonals are the ones that, like I said, you could count them a number of ways, and this is basically how you do them. And then in the end, I count the middle cell. Technically, this doesn't work if it's less than, if you don't fill the middle cell, but, whatever, right? But yeah, at the end of the day, apparently I had the answer earlier, but yeah. Because of this caching, you only do probably 2, I want to say 2 layers, but let's say 3 layers from the inner cell. So that means that you only calculate for 4 total layers or something like this. So then it just becomes 4 times the number of cells you have, 4 times 8 times 200,000 or whatever it is for me. So yeah. That's all I have for this one. Let me know what you think. It's a 5-hour and 16-minute video. Probably the explanation is a little bit fast, but definitely slow it down if you have to. I mean, it's all about observations, and those observations I do give you. And once after that, I wanted to say that the implementation is not that bad, but I actually got that pretty early, pretty quickly. Maybe not all of it, but most of it. And then I spent like 4 hours programming and getting off by ones and edge cases and stuff like this. So I don't know. But I'm still blaming on the jet lag. I didn't sleep that much. So yeah. But that's all I have for today. I am going to pass out. So stay good, stay healthy, to good mental health. I'll see you out later and take care. Bye-bye.